Hello everyone, welcome to our first apple pie video, and to start off we're doing square roots and prime factorization. I'm kind of slamming two topics together here because it's so similar. If you've learned prime factorization, you can pretty much get square roots right away. So, the definition of a square root is a number that when multiplied by itself gives, well, a number. So the square root of x is, you can think of this another way as the side length of a square with area x in this diagram. So an easy way to put this together is if you think about a square with area 9, the square root of 9 would be 3 because 3 times 3 equals 9. It's just a number that when multiplied by itself gives a specific product. So let's test out our prime factorization using an arbitrary number, let's say 1575. So what we're going to do first is look at our number and try to find something it's divisible by, so 5. If we divide 5 out of 1575 right away, we're going to get down to 315. And if you see what we're doing here, we're doing the same process over and over again. Every time we're dividing out another prime number. So we're working through these prime factors, these 5, 5, 3, 3, and 7. As you see, we get to the end when we've divided out all the prime factors we can. We're left with 7 at the bottom there, which means we can't go any further. So at that point, we've got our prime factors. 2 5s, 2 3s, and a 7, so I'm going to mark them off here. And this is, so the numbers you have at the beginning there, the 315, 63, and 21 are not important. The only ones you care about are these prime numbers. So what I'm going to do now is put them back together like this, but into the exponent form this time. So we have 5 squared, 3 squared, and 7 to the first, or just 7. 7 to the first and 7 are the same thing. So a lot of people just leave it at 7 or don't have a, to the first there because it means the same thing and it's just kind of extra numbers. So what I'm going to do again, our final step in the prime factorization is going to be to put them together, but in a different form. We're going to multiply them by each other. So we're going to have 3 squared times 5 squared times 7. Alright, so what I'm going to show you next is kind of a graphic representation of what we're doing when we take a square root. So if you remember back at the beginning, I told you that a square root is essentially the side length of a square with area x. So the side length would be roots of x. So what we're going to do here is kind of walk through that with an actual number. So if we have our prime factorization of 1575, which is 3 squared times 5 squared times 7, we're going to expand that back out into 2 3s, 2 5s, and a 7. And I'm going to draw this square just to help us keep track of what we're doing. So what we're going to do now is look for pairs of numbers, like these 2 3s, and we're going to split them off to go to either side of the square, because both squares have to have the same length, so we have to split them off into groups like that, so they both go to either side. And we're going to do that again with the 2 5s. So they're splitting off to go to both sides of the square. Now when we get to this 7, we can't split it off into 3.5 to either side, and we can't just, we have to do something different with the 7, because we're doing a different kind of operation than just multiplication or division. So we know we have the 3 and the 5 on either side here, but the 7 we're kind of stuck at. So the only good way to do this, it's not a very elegant solution, but we have to leave that as a square root of 7 on either side, which is, it's kind of a circular definition to have the square root of a number include a square root in the answer. But with prime numbers, sometimes that's the best you can do. So we have to leave that as 3 times 5 times root 7 for our answer, for the dimensions of the square. And you can simplify that out to being 15 times root 7. So 15 times the square root of 7 is our answer for this root, for the square root of 1575. That's what we come to. Let's try the prime factorization of a new number. Let's say 3969. So on this number, we're going to do a different method of prime factorization. This is a method that's more commonly used, but I don't like it very much just because it's not terribly effective unless you can see numbers that are pretty big right away. Here's what I mean. There's 81 and 49. So if we take these two numbers out, we can then basically follow the same process as earlier, but it's going to look a little bit different. It's going off in more directions, a little more chaotic. So we're going to eventually work this through to get 4 3s and 2 7s. We have 3 times 3 times 3 times 3 times 7 times 7 as our prime factorization. So we're going to circle those. So you see the diagram, it's the same thing as we did earlier, but instead of splitting off one prime number at a time, we're splitting off bigger numbers in a group. So we have our prime factors here. What we're going to do now is multiply them by each other, put them together like this. And from there, we can see that we have 3 4s and 2 7s, and we can put them back into that exponent form that we were using earlier. And that's one form of our prime factorization. So with our prime factorization of this new number, we have 3 to the 4th times 7 squared. So this is the more practical method. The last one I showed you with that square, that's more just conceptual understanding what we're doing. This is what you probably want to do if you're taking a test or something. This is the much easier, faster way to work through it. So we're going to expand this form back out into our multiplicative, all these numbers multiplied by each other. And we're going to do the same thing, which is looking for pairs of numbers. So we see here we have 4 3s and 2 7s. So we have 2 pairs of 3s and 1 pair of 7s. So we're going to split these. Each one of these pairs is going to be reduced to just one of each number. So we're going to have the 2 3s go to 1, 2 3s go to 1, and 2 7s go to 1. So this is not half of our original number, but it's a portion of it. So what we have now, this 3 squared times 7, this is your entire answer. You're done at this point. The square root of 3963 comes down to 3 squared times 7, which multiplies out to be 63. But if you look here, what we've done from the original prime factorization is all of these exponents have gone down, they've all been divided by 2. So we have 3 to the 4th gone down to 3 squared, and 7 squared gone down to 7 to the 1st. So this is essentially what we're doing when we take the square root of a number. We're taking the prime factorization of it and dividing these exponents by 2. So that's the very easy, kind of fast way to do it if you just want to get your answer. This is essentially what we're doing, is dividing these exponents from prime factorization by 2 to get your square root answer. So one more thing we should go over before we finish out here is how to do higher roots. So square roots are, the side length of a square with area x, but we can also do cubed roots, which are the side length of a cube with area x. So we do this a very similar way. Let's take 81. We're just going to do the same tree, get the same prime factors, but instead of now looking to divide them into groups of 2, we're essentially going to divide them into groups of 3, because we're trying to, equally split them off into 3 different sides of a cube rather than 2 different sides of a square. So we're going to do the same thing as we usually would. We look for groups of 3 though instead of groups of 2. So in this case we have 4 3s, so we can get one group of 3 3s. And with that leftover 3, instead of leaving that as a square root, we're going to leave that as a cubed root this time. So whatever is left over extra is going to be stuck as a cubed root, which is kind of written as a square root sign with a 3 over it. So lots of 3s in this answer. And you could do the same thing with even higher powers of roots. So, 4th roots, 5th roots, you really won't see any of that. I mean, you pretty much never see cubed roots. So 4th and 5th roots especially will be pretty rare, but just in case you do, now you know how to get them. Alright, so just a quick review, going over again how to get square roots. Remember our 3 steps, a couple steps. We have our prime factorization. First, get the prime factors, put them into exponent form, and divide the exponent groups by 2. To get your square root answer. Any exponents that can't be divided well by 2 can be left as the square root of the number themselves. Then you multiply the numbers that you have back out to get the simplified form, which in this case would be 35 times root 2. Hi everyone, thank you so much for watching our first apple pie video. This is of course the first of many. Eventually we'll have videos coming out 2 or 3 times a week. If you have any questions about either this video, something you didn't fully understand or that you want to go over again, or a video that you really want to see, something you think should be pushed up, we have a list of episodes actually that we're going to release. And if we get a bunch of comments and we want to see something more than another, we can change around that order a little bit to help you guys out. So if you want to stay posted and catch all the latest videos we upload, you can subscribe below, you can like our videos, it means a lot to us. And thank you very much for watching. See you soon.